This is 4.6, Day 1, the Fundamental Theorem of Algebra. So the core concept, the Fundamental Theorem of Algebra, the theorem states that if f of x is a polynomial or degree and where n is greater than 0, then the function f of x equals 0 has at least one solution in the set of complex numbers. The corollary to that is that if f of x is a polynomial degree n where n is greater than 0, the equation f of x has exactly n solutions, provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3 solutions, and so on. So knowing that information, let's take a look. So in the equation 2x minus 1, it is degree 1, therefore there is one solution. The solution to this equation is 1/2. Then if we take a look at x squared minus 2, its degree is 2. The solutions would be root 2 and negative root 2, and therefore that is 2 solutions. X cubed minus 8, that is degree 3. The solution to this would be 2, and then minus 1 plus or minus I root 3. So these are 3 solutions. We have negative 1 plus I root 3, and negative 1 minus I root 3 plus the 2. So that's 3 solutions. Then the last one, the degree is 3. The solutions would be negative 1, and 1. And so again, that is 3 solutions. So the biggest thing to take away from this is that the degree, whatever the degree is a number of solutions that you would have. And again, if it's repeated solutions, if it's repeated twice, then that counts as 2 solutions. If it's repeated 3 times, then it's 3 solutions. But it still tells us how many solutions there are. So that's very helpful. We can always just take a look at that and know, well, how many should we have? So the corollary to the fundamental theorem of algebra also means that an nth degree polynomial f has exactly n zeros. So looking at the first one, how many solutions does the equation x cubed plus 3x squared plus 16x minus equals plus 48 equals 0 have? So for this one, we're going to go ahead and solve it. And so we can factor by grouping. The first one we can divide by x squared. The second group we can divide by a positive 16. And so this would become x squared times x plus 3 plus 16 times x plus 3, and that equals 0. So to put this together, this is x squared plus 16 times x plus 3 equals 0. Then, if you remember, x squared plus 16, we can factor that, or you can solve that. But this is x plus 4i, x minus 4i, and then the last one is the same at x plus 3. So you can see that we have 3 solutions. Okay, the solutions would be negative 4i, positive 4i, and a negative 3. So we have 3 solutions. Letter B, we can look at how many solutions that has. That has 4 solutions, and then we could actually solve for that. But this is x equals 0, negative 2, and negative 2. So go ahead and try number 1 and 2. I just want you to find out how many solutions we have. You don't have to solve for it all. Just tell me how many solutions there are. So pause it for a second, answer those questions, and then press play again. So if you solve for this would have 4 solutions, and the next one would have 3 solutions. And again, you didn't have to solve for it. You just had to find how many solutions there were. Now let's actually go into solving. Find the zeros of a polynomial function. So we have x to the 5th plus x cubed minus 2x squared minus 12x minus 8. So looking at this, can we factor it as it is? No, we cannot. It is not factorable. And so we have to do, if you remember, the rational root theorem. So this is back over front. So we have to be 8 over 1. So the factors of 8 are 1, 2, 4. 1, 2, 4, and 8. So the possible roots of the solution are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, and plus or minus 8 over 1. So we need to do synthetic division. Let's try -1. So I am missing a 0. That's 0x to the 4th. I'm missing a term, the 4th. So this is -1, 1, 0. Let's see, 5, 4, 3, 2, 1, 0. So 1, 0, 1, -2, -12, and -8. So you bring down the first term. So that is 1. 1 times -1 is -1. 0 plus -1 is -1. This is positive 1. 1 plus 1 is 2. 2 times -1 is -2. And this is -4. This is positive 4. This is -8. 8 times -1 is positive 8, and therefore 0. So x plus 1 is a factor. And right now, if we're looking at this, this is x to the 0, x1, x2, x3, and x to the 4th. So this would be x plus 1, x to the 4th minus x cubed plus 2x squared minus 4x minus 8. Then looking at this, maybe it is not factorable quite yet. So what we're going to do is we're going to use a rational root theorem again. And we still have the same numbers because -8 is the back and 1 is the front. Let's go ahead and try -1 again in this case. So this is 1, -1, and 1 is -1. This is -2, positive 2, 4, -4, -8, positive 8, and -8 plus 8 is 0. So then we have another solution at x plus 1. Now let's see if I can factor this one. So this is x cubed minus 2x squared plus 4x minus 8. So looking at this, oh, I can factor that by grouping. So let's finish factoring that by grouping. So this is a solution, this is a solution, and that is a solution. So let's just work on that back piece here. So we have x cubed minus 2x squared plus 4x minus 8. I can divide the front by x squared and the back by 4. So this is x squared plus 4. Sorry, not yet. Let's say we have x squared times x minus 2 plus 4 times x minus 2. So this is x squared plus 4 times x minus 2. And then let's bring down the other 2. X plus 1 times x plus 1, and that equals 0. So the x squared plus 4, if we solve for that, we would get x squared equals -4, or x squared equals plus or minus 2i, or x equals, sorry, not plus from x squared, but it'd be x equals plus or minus 2i. Then we have x equals 2, and x equals -1 and -1. And if I count, that's 1, 2, 3, 4, 5 solutions. Okay, so that's how you would do this problem. You would have to use rational root theorem, actually factor it all the way, and then for the homework you will get some hints in order to help you finish it out as well.